Good morning. We have learned about the relations and the types of relations, reflexive relation, symmetric relation, and transitive relations. All types of relations we have learned. Now we are going to apply those relations in the problems. Exercise 1.1. Let us see the first question. A relation R in a set A is equal to, this is a set, and they have defined the relation R is equal to x comma y such that x 3x minus y is equal to 0. These are the x values. Go and substitute in this one so that we will get the y value. See, given here is 3x minus y is equal to 0. This implies y is equal to 3x. Now give the values for x and find the values for y. So that will be our relation. Now if I give the value 1, y value will be 3. If I give the value 2, 3 into 2, 6. Next 3, 3 3s are 9. Next 4, 4 3s are 12. Next give the value 5, 5 3s are 15. See here, this is going beyond the set given here. Therefore, this ordered pair will not come under relation. Only this will be there. Now this is our relation. In this relation, I have to check whether this relation is a reflexive relation, symmetric relation, or transitive relation. Condition for reflexive relation. Reflexive relation. What is the condition for reflexive relation? X comma x or a comma a. If this belongs to R, for all x belongs to capital A. Now see here, if x belongs to A means then x comma x should belongs to R. Whether that condition 1 is there, whether 1 comma 1 is there in the set, 2 comma 2, no, it is not there. Therefore, we can say that R is not reflexive. R is not reflexive. Now go for check the second condition. What is the condition for checking the second one? Symmetric reaction, symmetric reflection, symmetric relation, symmetric relation. Now if x comma y belongs to R means then y comma x also should belongs to R. Now see, x comma y, 1 comma 3 is there. 1 comma 3 belongs to R. Either 3 comma 1 is there. 3 comma 1 does not belongs to the relation. Therefore, directly I can say that R is not symmetric. Now go for the next one, transitive relation. Transitive relation. Now what is the condition for transitive relation? X comma y belongs to R and y comma z belongs to R. This implies x comma z should belongs to R. Now see here, 1 comma 3 belongs to R. The next one, 3 comma 9 belongs to R. X y is there, y z is there, but 1 comma 9 does not belongs to R. Therefore, R is not transitive. So in this given question, reflexive relation is also not there, symmetric is also not there, transitive also not there. Now let us see the second question. Show that the relation R in a set capital R of real numbers defined as R equal to A comma B such that A less than or equal to B square is neither reflexive nor symmetric and not transitive. If we have to prove that it is reflexive, symmetric and transitive means it is easy. By showing each and every element belongs to the R, we can show that it is reflexive, symmetric and transitive. If we have to prove that it is not belongs to the set means we have to check at least one ordered pair does not belongs to the relation, belongs to the set, then only it is not reflexive. Let us see in the sum. Given relation is R is equal to A comma B such that A less than or equal to B square. Now I want to show that it is a reflexive relation. See that given R is my set of real numbers. Real numbers include natural numbers, whole numbers, rational numbers, irrational numbers. All these numbers together forms the set real numbers. Now simply they have given only the relation. I have to select a number either from natural or from whole or from integer or from rational or from irrational number to show that this is not a reflexive relation. Now let us take a whole number and check. See, let us take the number 2 and 2. Go and apply in this one. What will happen? 2 less than or equal to 2 square will be 4. This is greater. This is true. So in whole numbers I have checked for one thing, the relation is true, but I want to prove that it is not reflexive. Now the same thing check for integer number also. Minus 2 is less than or equal to minus 2 whole square will be there, so that also greater only. See here 4, so this also is greater. Now whole numbers I have checked and integer number I have checked for one number. Now go for the next number, rational number also. Take any rational number. Let us take the number 1 by 2 and 1 by 2. Now see here 1 by 2 less than or equal to 1 by 2 whole square will be 1 by 4. Now see in this one which is greater here, 1 by 2 is greater, so this is not true here. Therefore I can say that at the place of rational number reflexive relation is not there. Therefore R is not reflexive as 1 comma 1 by 2 comma 1 by 2 does not belongs to this relation. Now check for the symmetric. Check for the symmetric. Take any number. Let us take minus 1 and 2. Now check here. Symmetric means minus 1 2 should satisfy the condition, then 2 minus 1 should satisfy the condition. Now minus 1 less than or equal to 2 square, so this is greater, that satisfies. Now next go for the next one, 2 less than or equal to minus 1 whole square. Whether this condition satisfies? No, this is not satisfied. Therefore minus 1 comma 2 belongs to R, but 2 comma minus 1 does not belongs to R. Therefore R is not symmetric. Next, check for transitive. Let us take the number 4 and 3. For the transitive, a comma b should belongs to R, b comma c should belongs to R, so that a comma c should belongs to R. This I have to prove. These two are there means then this should be there. Now let us take a set a comma b belongs to R and b comma c belongs to R. Then we will prove that a comma c does not belongs to R. See 4 comma 3. A less than or equal to b square means 4 less than or equal to b square, it is 9. Here condition satisfies. The next thing I have to select for b and c. B value I know 3. C value I have to select a number such that this condition will be true. Now more than 3 but less than 4, let us take decimal number. Let us take a decimal number. See 1.8. Why I am taking 1.8 means the next C should goes in square. So when I square this value, it will be around 18 square means 324. So it will be 3.24 more than 3. So that's why I have selected this number 1.8. Now 3 less than or equal to 1.8 whole square. So 3 is less than or equal to 3.24. Now this is greater, this is smaller. Now see here 4 comma 3 I have selected, here 3 comma 18 I have selected. A comma b belongs to R, here b comma c belongs to R I have taken. Now go for the next 4 comma 1.8. 4 comma 1.8 means 4 less than or equal to 1.8 the whole square, that is 4 less than or equal to 3.24. This does not satisfy, so a comma c does not belongs to R, therefore R is not transitive. So I have proved that it is not reflexive, it is not symmetric, and it is not transitive. We have to check for each and every number at what place this is not satisfying, that we have to check.